Okay, what we're going to talk about today is we're going to factor, but we're actually going to solve. We're going to. That is Sydney that's making that noise and disrupting the class. Okay, so today we're going to not only factor, we're going to solve by factoring. So it's all the stuff that we've been doing for factoring polynomials, but we're going to take it one step further and solve it. Now, for today's homework, it's going to say only the real number solutions. So let's say, for example, that after I factored it, I would have a 0 that would be like x squared plus x squared plus 1. Let's say I had x minus 3 and something that said 4x minus 7 equal to 0. If I had those after factoring, what we're going to do today is we're actually going to find the real zeros. So let's take this x minus 3 factor, and the 0 for that would be x equal to 3. For the 4x minus 7 factor, if I couldn't tell what the 0 is by looking at it, I could set up a little equation that says 4x minus 7 equal to 0. 4x is equal to 7. X is equal to 7/4. So there's my second 0. And then I'm going to come over to the x squared plus 1, and to figure out what that makes that go to 0, I'm going to set up a little equation saying x squared plus 1 equal to 0. X squared equals a negative 1. Now I'd take the square root of both sides, which would be x is equal to plus or minus the square root of a negative 1. And you can see that my answer is actually going to be imaginary. So though at some time we may use that, and the answer would be plus or minus I. For today, we're saying only the real zeros, the real number zeros. So when I saw this, I didn't even have to carry it that far because that's going to be an imaginary number. My only real number zeros would be those two. So we can forget about the imaginary zeros and not even work it that far. Something else to notice, that if I happen to have an x outside of the parentheses, the value of x that makes the whole equation go to 0 would be x equal to 0. So if we do have something like that in some of these, we're going to have to be aware that that also has to count in the answer. So here's the first problem we're going to work. Okay, so if I had that, notice it's set equal to 0. That means the y value is already equal to 0. So all I have to do is factor that and figure out what values of x makes that go to 0. The first thing I'm going to do is see if I could factor anything out of it, and I can. I could get a 2 out. I can get an x out because every term has an x. That would give me x squared minus 6x plus 9 equal to 0. Now I'm going to look at my quadratic term, the one with the squared, and I'm going to see if I could factor that. Two numbers that add to negative 6 multiplied to 9. That would be x minus 3 and x minus 3. So for this particular problem, the value of this x that makes it go to 0 is x equal to 0. This parentheses is x equal to 3. And I have another x equal to 3, and those would be my zeros for that problem. Okay, moving to the next, another problem. So that was one of the factoring techniques we had yesterday, was to factor out any common factor. Okay, let's go to another problem. Okay, here's a problem. Now notice it doesn't have a lot of terms, but it kind of looks like a difference of squares, and it is. The only difference is it has a fourth power term. So when I factor it, its terms are going to have squareds. So what I would do is let me change that. That looks better. So if I had 16x to the fourth minus 9, when I factor it as a difference of squares, actually I'm going to change that too, sorry. So when I factor that, so now this is the problem I have, 16x to the fourth minus 81. If I factor that and break that up into a difference of squares, I'm going to have 4x squared minus 9. 4x squared plus 9 equal to 0. The 4x squared plus 9 cannot be factored any further, but the 4x squared minus 9 can. That's going to be 2x plus 3, because that's a difference of squares, 2x minus 3. Then I have 4x squared plus 9 equal to 0. So let's find out what my zeros are. For the 2x plus 3, that would be x is a negative 3 halves. For the 2x minus 3, that would be x is equal to a positive 3 halves. And for this piece here, I would start to be working on it. So I would say 4x squared plus 9 equal to 0. Then I would subtract 9. Now I would divide by 4. And you can see now that actually if I take the square root of both sides, I'm going to have the square root of a negative number. So this whole side would be imaginary, and I wouldn't have had to work that. So that's an imaginary number. The only two real zeros I would have would be x is a plus or minus 3 halves. Okay. Next problem. Wrong problem. Okay, so here's another problem that I have. This will require a different kind of factoring technique. It's got a cubic, a squared, an x, and a constant term. So the way to factor this is by a difference, is by grouping. So for this kind of a factoring, I'm going to split it down the middle. I'm going to pull out the common factors from the left side. That would be x squared, and I would have x minus 5 left. So I have to have x minus 5 on the other side. To get this to be x minus 5, I have a plus going to a minus, so I'm going to have a subtraction, and I would factor out a 4. Let's check that. Negative 4 times x is a negative 4x. A negative 4 times 5 is a plus 20, so that works. So my factors are x squared minus 4. X minus 5 equal to 0. So for the x squared minus 4 factor, that's a difference of squares, x plus 2, x minus 2. And I still have my x minus 5 equal to 0. So I have x is a negative 2, x is 2, x is 5. Those would be my zeros. They're all real numbers. One more example of how to solve, and it's also how to factor. So if I have 4n to the fourth plus 40n plus 84 equal to 0, and I have to factor it. So what kind of factoring technique will I use? Well, it's not a difference or sum of cubes. It's also not going to be grouping because I don't have 4 terms. It is quadratic form where I have the form, actually that's a square. I have a constant term, then I have an exponent here, and the exponent that's in the front is twice the middle exponent. So that's quadratic form. So it's going to factor just like similar to if I would have 4n squared plus 40 n plus 84. So I would use the same techniques. So the first thing I'm going to do is factor out of 4. And I'm going to get n to the 4th plus 10n plus 22 equal to 0. That's 21. Okay? So now then I'm going to factor this centerpiece just like I would a quadratic, except the terms will be squared terms. So two numbers that add together to be 10 and multiply to be 21 would be a 7 and a 3. So this would be n to the 4th plus 7. That's squared. N squared plus 7, n squared plus 3 equal to 0. So now then I have to find the values that make these go to 0. So for the n squared plus 7, I'd say n squared plus 7 is equal to 0. N squared is equal to negative 7. We can see right there that that's going to be an imaginary number. So there are no real solutions on that part. For the other part, this would be n squared plus 3 equal to 0. Move the 3 over, n squared is a negative 3, and once again we can see that if I take the square root of both sides, this other side would also give me an imaginary number. So for this particular problem, although it would have 4 imaginary zeros, we're not going to use the imaginary zeros, we're looking for real roots. This would have 0 real roots. Okay, the last piece I want to show you is a totally new technique. Right, for these kind of problems, we need to find the zeros of, like number 10. It cannot be factored by grouping, but they're giving us one of the zeros. So what I'm going to do is use synthetic division to help me find the other zeros. So what I'm going to do is if I know one of the zeros is 1, I'm going to set that up outside my synthetic division box. And then, of course, with synthetic division, we're going to pull the coefficients off. That coefficient is 1. The coefficient on the x squared is 1, a negative 17, and a negative 15. And the number I'm going to use outside is the 0 that they give me, 1. So if I do synthetic division, I bring down the 1. 1 times 1 is 1. I put the 1 in the second column. Add, I get 2. 2 times 1 is 2. So I bring the 2 over. I add, I get a negative 15. Negative 15 times 1 is negative 15. I put it in the next column and add. And what I get is my remainder is equal to 0. That means that this 0 here is a 0. And what the factor would be for that 0, of course, if the 0 is x equal to 1, then the factor is x minus 1. And what it gives me at the end is a perfect factor. Because this is the remainder is 0, x, this is the x column, x squared column, this is x, this is the constant, that's the remainder, that x squared plus 2x minus 15, that has to be a perfect factor of what I started with because the remainder is 0. So now all I have to do is factor what I got left from the synthetic division, and I would have the zeros. So this would be x plus 5, x minus 3 equal to 0, x is equal to a negative 5, x is equal to 3. So what I did is because I knew one of my zeros, I was able to use it with synthetic division, and I was able to come up with the squared factor at the end that was a perfect factor, and if I factor it, I get my zeros.